Oftentimes, we are interested in estimating the true mean of a population of interest. We take a random sample from the population, and from the sample we can compute a point estimate and interval estimate of the mean. In computing a confidence interval estimate for the mean of a population, we can use the z-distribution or the t-distribution, whichever is applicable. Recall that in Chapter 8, we discussed the conditions when to use the z or the t distributions. We apply those same conditions here. So on this slide, we show the formula for computing a confidence interval estimate for the mean of a population when the population's standard deviation is known. When sigma is known, the z-distribution is used in computing the margin of error. In the formula for computing the confidence interval estimate, we see the two components, which are the point estimate, x bar, and the margin of error, e. We add the margin of error to the point estimate to obtain the upper confidence limit. We subtract the margin of error from the sample mean to obtain the lower confidence limit. Based on this formula, we observe that the width of the interval is determined by the level of confidence and the size of the standard error of the mean. The standard error, in turn, is affected by two values, the standard deviation of the population and the sample size. So how do we interpret an interval estimate? The interpretation of a 95% confidence interval means that if we constructed 100 confidence intervals for the mean using the same sample sizes, about 95 of these confidence intervals will contain the true population mean. We normally interpret a 95% confidence interval as we are 95% confident that the true population mean lies within the lower and upper limits of the interval. Here we show an example of how to compute a confidence interval for the mean of a population whose standard deviation is known. The American Management Association wishes to have information on the mean income of middle managers in the retail industry. A random sample of 256 managers reveals a sample mean of $45,420. The standard deviation of this population is $2,050. The association would like answers to the following questions. 1, what's the population mean? 2, what's a reasonable range of values for the population mean? And 3, what do these results mean? In the AMA example, we are asked what the population mean is. In this case, we do not know. But we do know that from a random sample of 256 managers, the sample mean is $45,420. This gives us a good initial estimate of the unknown population mean. The sample mean of $45,420 is a point estimate of the unknown population mean. However, point estimates are often insufficient. In the following slide, we show how we extend this estimation using a confidence interval estimate. A confidence interval estimate is more informative than a point estimate. In this situation, the population standard deviation is given. As such, we will be using the z-distribution in computing the 95% interval estimate of the true mean income of middle managers in the retail industry. Before we show how we compute the confidence interval estimate for the true mean income of middle managers in the retail industry, let us first see how the 95% confidence level is converted into a z-value. So in obtaining the z-value for a 95% confidence interval, we use the standard normal distribution table. A 95% confident interval estimate means that the middle 95% of the observations lie within the upper and lower interval limits. Therefore, the remaining 5%, which is the difference between 100% and the confidence level of 95%, are equally divided between the two tails. As such, 2.5% is on one tail and the other 2.5% is on the other tail of the distribution. So we are going to use Appendix B1, the table on that page, to find the z-value we're going to divide 95% by 2 to give us 47.5%, or 0.475. Looking at 0.475 in the table yields a z-score of 1.96. Another way of obtaining the z-score is by using the Excel function, which is listed here on this slide. So now let's revisit the example introduced in an earlier slide where a random sample of 256 managers revealed a sample mean income of $45,420. The standard deviation of this population was stated as $2,050. The sample mean of $45,420 was our best estimate of the unknown population value. Using a 95% confidence interval, what is a reasonable range of values for the population mean? We can compute the 95% confidence interval for the true mean by using the formula on this slide. In this formula, X bar, the sample mean, is $45,420, and sigma, the population standard deviation, was given as $2,050. Using Appendix B1, as shown in the previous slide, we find the z-value for a 95% confidence level as 1.96. So then we're going to substitute these numbers into the formula. We obtain the lower limit as $45,169 and the upper limit as $45,671. Based on these numbers, we can then conclude that we are 95% confident that the true mean income of middle managers in the retail industry is between $45,169 and $45,671. The margin of error of this estimate is $251. In the previous slide, we obtained the 95% confidence estimate of the true average income of middle managers in the retail industry using a sample of 256 managers as 45,169 and 45,671. So what exactly do these results mean? This means that if we select many samples of 256 managers, and for each sample we compute the mean and construct a 95% confidence interval for each sample, we could expect about 95% of these confidence intervals to contain the population mean. Conversely, about 5% of the intervals would not contain the population mean annual income, mu.